The contraction of a skeletal muscle generates the force necessary to move the skeleton. A contraction is triggered by a series of molecular events known as the cross-bridge cycle. In a skeletal muscle fiber, the functional unit of contraction is called the sarcomere. A sarcomere shortens when myosin heads in thick myofilaments form cross bridges with actin molecules in thin myofilaments. The formation of a cross bridge is initiated when calcium ions, released from the sarcoplasmic reticulum, bind to troponin. This binding causes troponin to change shape. Tropomyosin moves away from the myosin-binding sites on actin, allowing the myosin head to bind actin and form a cross bridge. Also note that the myosin head must be activated before a cross-bridge cycle can begin. This occurs when ATP binds to the myosin head and is hydrolyzed to ADP and inorganic phosphate. The energy liberated from the hydrolysis of ATP activates the myosin head, forcing it into the cocked position. A cross-bridge cycle may be divided into 4 steps. Step 1. Cross-bridge formation. The activated myosin head binds to actin, forming a cross bridge. Inorganic phosphate is released, and the bond between myosin and actin becomes stronger. Step 2. The power stroke. ADP is released and the activated myosin head pivots, sliding the thin myofilament toward the center of the sarcomere. Step 3. Cross-bridge detachment. When another ATP binds to the myosin head, the link between the myosin head and actin weakens, and the myosin head detaches. Step 4. Reactivation of the myosin head. ATP is hydrolyzed to ADP and inorganic phosphate. The energy released during hydrolysis reactivates the myosin head, returning it to the cocked position. As long as the binding sites on actin remain exposed, the cross-bridge cycle will repeat. And as the cycle repeats, the thin myofilaments are pulled toward each other and the sarcomere shortens. This shortening causes the whole muscle to contract. Cross-bridge cycling ends when calcium ions are actively transported back into the sarcoplasmic reticulum. Troponin returns to its original shape, allowing tropomyosin to glide over and cover the myosin-binding site on actin.